Imagine standing in front of a wall that logic insists is impenetrable. You've tried before. You've calculated the risk. You've gathered the evidence. And everything, experience, memory, prediction, says, this is as far as you go. In classical physics, that conclusion would be correct. If a ball doesn't have enough energy to roll over a hill, it rolls back. If a system lacks sufficient force, it fails. Newton's world is clean, deterministic, linear. But when physicists began studying the behavior of particles at extremely small scales, something unsettling happened. Particles stopped obeying those rules. They encountered barriers they did not have enough energy to cross. And yet, they appeared on the other side. Not by smashing through, not by climbing over, not by borrowing extra energy, but by doing something stranger. They tunneled. This phenomenon, quantum tunneling, is not speculative. It is experimentally verified. It powers nuclear fusion in stars. It explains radioactive decay. It makes modern electronics possible. Your phone works because particles sometimes cross walls they are not supposed to cross. And that raises a profound question. If the universe itself does not treat barriers as absolute, why do we? You think you're facing a wall, but physics suggests you might be facing a probability field. To understand this, we need to clarify what quantum tunneling actually is. In quantum mechanics, particles are not tiny billiard balls. They are described by wave functions, mathematical probability distributions defined by the Schrödinger equation. A wave function does not tell us where a particle is. It tells us where it could be found. When such a wave encounters an energy barrier higher than its available energy, classical physics predicts total reflection. But quantum mathematics predicts something else. There's a non-zero probability that the wave function extends through the barrier. If measured, the particle may be detected on the other side. The barrier is not broken. It is not ignored. It is penetrated because the particle behaves as a spread-out probability cloud, rather than a fixed object. Richard Feynman described quantum mechanics as nature as it is, absurd from a classical perspective, but experimentally undeniable. This is not magic. It is a shift in model. At small scales, reality is not governed by force alone. It is governed by probability amplitude. And once you understand that, you begin to see how misleading classical intuition can be. And once we accept that barriers can be probabilistic, we have to ask whether our own mental walls function the same way. Now, let's be careful. The brain is not a quantum particle tunneling through skull barriers. We are not claiming mystical physics inside neurons, but the brain is probabilistic. Modern neuroscience, especially predictive processing models developed by researchers like Carl Friston and Lisa Feldman Barrett, shows that the brain is fundamentally a prediction engine. It does not simply react to reality. It predicts reality. Your brain constantly generates models about what will happen next. Those models are based on past experience. When reality matches prediction, the system stabilizes. When it doesn't, prediction error forces revision. Over time, repeated experiences strengthen certain predictions. Failure in public speaking becomes a reinforced prediction of anxiety. Financial instability becomes a reinforced prediction of scarcity. Relationship rejection becomes a reinforced prediction of abandonment. These reinforced predictions function like high-energy barriers, not because they are mystical, but because they are energetically costly to override. The brain is metabolically expensive. It consumes about 20% of your body's energy. It prefers efficiency. It prefers familiar pathways. So when you attempt something that contradicts your strongest predictions, your system resists. Stress hormones rise. Cognitive flexibility narrows. Attention constricts. You interpret this physiological response as, this must not be possible, but what you're experiencing is not an objective wall. You're experiencing a high probability prediction field. So, maybe breakthroughs are not about force. but about altering probabilities. Grind culture teaches us that the solution to resistance is more effort. Push harder. Work longer. Force the outcome. If resistance is rooted in predictive probability, increasing force without modifying the underlying model may simply reinforce failure. In quantum tunneling, the probability of a particle crossing the barrier depends on specific parameters: barrier height, barrier width, particle energy. Let's translate carefully. Barrier height resembles emotional intensity attached to a belief. Barrier width resembles repetition history, how long and how often that belief has been reinforced. Particle energy resembles cognitive flexibility, openness to new data, emotional regulation, exposure to alternative outcomes. If emotional charge decreases, the effective barrier lowers. This is not metaphorical. Memory reconsolidation research, pioneered by neuroscientists like Kareem Nader, shows that when a memory is reactivated and paired with new emotional context, it becomes temporarily malleable. The memory is not erased, but its intensity can change. And when intensity changes, predictive probability changes. The barrier doesn't vanish. Its height decreases. And once probability shifts sufficiently, crossing becomes statistically viable. Not guaranteed. Viable. That distinction matters. And when probability shifts enough, change often looks sudden, but it was never instant. One of the most misunderstood aspects of breakthrough moments is their apparent abruptness. A person struggles for years to leave a career. Then suddenly they resign. An individual battles anxiety for decades. Then seemingly overnight they begin acting confidently. From the outside, it looks miraculous. From a systems perspective, it looks like a phase transition. In physics, phase transitions occur when a system crosses a threshold. Water remains liquid as temperature rises, until it reaches a critical point. Then it becomes vapor. The transformation appears sudden, but it was building incrementally beneath the surface. Psychological change operates similarly. Neural plasticity research over the past decade has shown that identity level shifts can accelerate when emotional salience and focused attention align. Attention acts as a stabilizing force. In quantum mechanics, measurement collapses a wave function from probability distribution into definite outcome. In cognition, attention reinforces certain neural pathways over others. Where focus goes, synaptic reinforcement follows. When a new prediction becomes strong enough, behavior reorganizes around it. And from the outside, it appears like tunneling. But it was probability modulation reaching critical mass. The real breakthrough is not crossing the wall. It's changing how you interpret it. There's something psychologically liberating about understanding this. If you believe obstacles are solid and absolute, your strategy is limited to force. If you understand obstacles as probability structures, your strategy becomes architectural. You ask different questions. Instead of, how do I break this? You ask, what determines the barrier height? Instead of, why am I failing? You ask, what prediction is my brain protecting? This shift alone can reduce emotional reactivity. And reducing emotional reactivity lowers barrier height, which increases probability. This is not mystical thinking. It is model refinement. Collapsing the breakthrough gap requires a protocol, not just inspiration. So how does one practically apply this? Not by visualizing particles walking through walls, but by working directly with predictive models. A grounded protocol looks like this. First, identify the dominant prediction, not the surface complaint, the underlying forecast. Second, safely reactivate the memory or belief while introducing contradictory evidence. This can occur through cognitive reframing, graded exposure, or emotionally corrective experiences. Third, reduce physiological arousal. Emotional intensity strengthens barrier height. Regulation lowers it. Fourth, introduce repetition of the new model. Neural pathways strengthen with rehearsal. Fifth, stabilize identity around the updated prediction. This is consistent with modern cognitive behavioral approaches, exposure therapy models, and memory reconsolidation research. The wall weakens because the brain updates its model, not because reality bends, but because perception shifts action, and action reshapes outcome probabilities. But once you cross into a new state, maintenance becomes the real work. Quantum particles do not doubt their transition. Humans do. Old pathways remain available. Regression is common not because change was false, but because competing predictions still exist. The brain prefers metabolic efficiency. Familiar routes are easier, so operating in a new probability state requires reinforcement. Environment matters. Language matters. Social context matters. Carol Dweck's work on mindset demonstrates how belief framing influences persistence. James Clear's work on habit formation shows how identity-based habits stabilize behavioral shifts. Predictive processing suggests that repeated confirmation strengthens expectation. Maintenance is not glamorous, but it is how a tunneled state becomes a new baseline. And when you begin to see obstacles as fields rather than walls, strategy evolves. This perspective does something subtle but powerful. It reduces existential fear. If an obstacle is absolute, failure becomes identity. If an obstacle is probabilistic, failure becomes data. You are no longer confronting a brick wall. You are navigating a probability landscape. That changes posture. That changes physiology. That changes behavior, which, in turn, changes probability again. The system becomes dynamic. And suddenly, impossibility feels less solid. Not because the universe guarantees success, but because you recognize that certainty was an illusion imposed by an outdated model. Quantum tunneling did not eliminate barriers from the universe. It revealed that barriers were never as solid as classical physics assumed. In the same way, understanding predictive neuroscience does not eliminate difficulty from life. It reveals that many of the walls we confront are reinforced expectations, probability fields, high-energy predictions. And when you begin to work at the level of probability rather than force, you stop exhausting yourself trying to break walls. You start modifying landscapes. The next time you face something that feels impossible, ask yourself, is this a solid barrier? Or is it a probability distribution I've mistaken for certainty? Because sometimes, the most profound breakthroughs don't come from pushing harder. They come from realizing that the wall was never absolute to begin with. And that changes everything.